In the previous lecture, we were talking about the geometric properties and the equations of parabolas, ellipses, and hyperbolas. So here I put all the information here back for you. A parabola, well, now it's not y equals ax squared plus bx plus c anymore because we are using the focus and the directrix. So the parabola, all of them, by the way, all these equations have center at the origin. Okay, so the parabola is the one with focus. Well, when you have x squared equals 4py, then, well, the focus is on y. It happens on y, so you have the focus here, and you have y equals p, y equals negative p here, and the parabola goes this way. Okay, and then for ellipses, we are having this equation has the higher denominator under x squared, so the major axis will be on x. So we are having negative a and a here, and we have b and negative b here, and your ellipse will look like this. Okay, and the foci happens where c equals square root of a squared minus b squared, which happens on the major axis. And if among these two denominators, if the denominator of y squared is higher, the graph will be the foci and the longer axis, the major axis, will be happening on y-axis, and then the minor axis will be on x-axis. It will look like this instead. Okay, if the denominator of y squared is higher than the denominator of x squared. Now the third one, the hyperbola, we don't care about which denominator is higher. We care about which term is positive. Okay, so the positive squared term is where the vertex is happening. So here it happens on x-axis because the x squared term is positive, and the vertices is where x equals a and negative a, and we don't really have b, well, the other denominator reflected in the graph, on the graph, but actually it contributes to how the graph shapes by being or contribute to the asymptotes. So when you make the equation equal to 0 instead of 1, you are going to get these two equations, and that's where you have the asymptote. Okay, then your hyperbola will go like this and this, and the foci actually is outer than the vertices. And remember, all these curves, they are holding the focus, okay, or the foci, so they all curl toward that way. But again, in all these three equations, 1, 2, 3. Okay, in all these three equations, the center, or if you look at the graph, the center for the parabola actually is the vertex, and then the center of the ellipse and the center of the hyperbola are the origin. And now is the point that we are learning in this class, which is the shifting. If we are going to replace x by x minus h or y by y minus k in the equations, we are actually still getting the shapes of parabola, ellipse, and hyperbola, respectively, but we are shifting the center to hk. Okay, we're shifting the center to the new point. And now we are going to talk, in this lecture, we are going to talk about how the shifted parabolas, ellipses, and hyperbolas have how their equations are look like, or if I describe those shapes for you, how can you recover the equations? Or if I give you the equation, can you sketch the graph? Okay, so we're still doing the back and forth between the graph and the equations, but now the center are not the origin anymore. Okay, first example, we are looking for the equation of the ellipse with foci 2, -2, and 4, -2, and then the vertices 1, -2, and 5, -2. Well, yes, sketching a graph might be helpful if you want to, but I'm trying to show you how you do it without really sketching the graph. So to start with, the whole thing is about you want to get the graph, you want to get the equation of the ellipse. Then the ellipse has equation x squared over a squared plus y squared over b squared equals 1, right? You need to get a, you need to get b. Also, you need to know the major axis happens on x or y. And then also you need to know the center. Let's see. Foci, the center is the midpoint of the two foci. It's also the midpoint of the two vertices. It's also the midpoint of the two endpoints of the minor axes. Okay, minor axis. So pretty much having any pair of them, you get the center. So with the foci 2, -2, and the 4, -2, we already can find the center, which is happen at 2 plus 4 over 2, which is 3, and then -2 and -2, of course, is -2. Okay, by looking at the foci, we know that our center happens at 3, -2. Then, comparing foci and center, you know that C is the distance from any of the two focuses, any of the two foci to the center. So let's do 4, comparing to 3, okay? So C equals 4 minus 3, which is 1. Now, looking at the vertex, which is, well, again, any of the two, I'm going to take the positive point, and comparing the vertex and the center, you know that the distance from the vertex, which is the A, to the center is 5 minus 3, which is 2. And you have A, you have C. You know that A squared minus B squared equals C squared. So 2 squared minus B squared equals 1 squared. B squares to 3. And also we know that our vertex or the major axis happens on X. So without shifting, the graph will look like x squared over a squared plus y squared over b squared equals 1. Or, well, then, let me now do 2 steps. It might be confusing. Actually, let me just do everything together. So our equation would be x minus the x coordinate of the center over a squared is 4 plus y plus the shifting y plus 2 squared over the b squared, which is 3, equals 1. That's the equation. You plug in a and b in the equation, and meanwhile you deal with the x and y by doing their shifting. Next example, we are looking for the equation of a hyperbola, where we know the foci are -3, -7, -3, -9, and then the vertices are -3, -4, and -3, -6. Positive 6. So again, you can use the foci, you can use the vertices. This time I'm going to use the vertices. It doesn't really matter actually. Our vertices are -3, -4, and -3, 6. That tells you the center happens at -3 and -3. X coordinate would be -3. And then the y coordinate is the average of those 2 points. So this is -3, -4 plus 6, 2 over 2, 1. So our center happens at -3, 1. That means you compare the vertex and the center. So comparing them, the distance is 5, and we're doing hyperbola. So this is a equals 6 minus 1 equals 5 on y. Then comparing any of the foci, again, I'm doing the positive one with the center, which is -3, 1. So comparing these, c equals 9 minus 1, which is 8. And a squared plus b squared equals c squared. So 5 squared plus b squared equals 8 squared. B squared equals 64 minus 25, which is 39. And the original equation should look like the a happens on y. So y term is positive. Y squared over a squared minus x squared over b squared. Well, let me write b squared equals 1. And then you bring them in. Y will be shifted by minusing 1, minusing this one, okay? Over a squared, which is 25, minus x plus 3 squared over the b squared equals 1. So here's the equation. Okay, now you can try practice number 1 and number 2. Now we are doing backward. We have the equation, which is a parabola, where the center or the vertex is not at the origin. We want to sketch its graph. So pretty much you need to complete that form, the x squared equals 4py form or y squared equals 4px form, but x and y are shifted. So let's see. First, you need to know this is a parabola with x squared term and only y term. So it will end up with some kind of y minus k equals 4p x minus h. Okay? So y equals 2x squared minus 4x plus 1. And I will combine the x terms together in the sense that I factor out the coefficient and I want x squared plus bx by itself. And I'll leave the plus 1 outside. Well, I don't really mean b. I meant 2. Then I'll complete the square. In order to complete the square, x squared minus 2x, you need to do -2 over 2 squared, which is -1 squared, which is 1. That's the number you need to add inside the parentheses. So meanwhile, you are actually adding 2 times 1, which is 2. Okay? So this is y plus 2 equals 2 times x squared minus 2x plus 1. That's x minus 1 squared plus 1. Then we cancel that 1. We have y plus 1 equals 2x minus 1 squared. Or I'm going to isolate the square term equals 1/2 y plus 1. X squared equals 4py. So 4p equals 1/2, which means p equals 1/8. And the center or the vertex happens at x then y, but both negated, 1, -1. And also this is on y. Okay, we have the vertex and we have, I need to find the vertex, the focus, and the directrix. So the vertex is 1, negative 1. The focus is supposed to be 0p, which means you are going to add p on top of the y coordinate. So focus will be 1, negative 1 plus 1/8, which is 1, negative 7/8. That's the focus. And the directrix is a line. So the base is y equals negative 1, then minus the p. So negative 9/8. Then we can put them together. We are having since I only have very small fractions, I'll draw the scale really big. 1, negative 1 is my, let me make it red, is my vertex, and then focus is just 1/8 above, and then the directrix is 1/8 below. Then the curve will go like this. I don't know where exactly it is, but it go past through the vertex, and also it open toward the side of the focus. So that's the graph. With, if I want to label the points, the vertex is 1, negative 1, the focus is 1, negative 7/8, and the directrix y equals negative 9/8.